Hi, welcome to the 5th session in the Hadoop tutorial series. I'm Ajay and today we're going to discuss about YARN. One of the main reasons for the birth of YARN in Hadoop is due to the scalability issue of MapReduce. So the prerequisite for this video tutorial is to check the previous tutorial on MapReduce. YARN was introduced in version 2 of Hadoop. The need for YARN is reasoned by some of the limitations of Hadoop version 1. MapReduce is great for many applications, but not for everything. Other programming models better serve requirements such as graph processing. The very big limitation in version 1 of Hadoop is its inability to execute non-MapReduce applications. Moving to the second limitation relating to issue with scalability, we had discussed during last tutorial that job tracker in MapReduce monitors the progress of the jobs executing in the client system. But the problem with the job tracker is that it cannot monitor jobs in more than approximately 5,000 slave machines. Hence, this limits the ability of the cluster to scale to a larger number. In simple terms, we cannot add more than approximately 5,000 servers to the cluster. Moving to the third limitation relating to resource utilization, in version 1 of Hadoop, the MapReduce does the resource allocation as well. It allots certain amount of resources for mapper execution and certain amount of resources for reducer allocation, and the allotted resources cannot be exchanged based on demand. This causes a major issue regarding resource utilization because take for example a MapReduce job is just submitted for execution. During the beginning phase of execution there is a lot of requirement for mapper resource and there isn't enough resources to handle them. On the other hand, there are very few reducer tasks to be executed and the resource available to handle them is very much in excess. Hence there would be mismatch and wastage in resource utilization. YARN was developed to simply overcome the above limitations in Hadoop version 1. To understand how these issues are solved using YARN, we first need to review the part of MapReduce found in version 1 of Hadoop. It has three main parts. First is the MapReduce API, the second one is the framework which takes care of the entire workflow of MapReduce operation. The third is the resource management which is responsible for scheduling jobs, allocating resources for mappers and reducers, monitor the map and reduce jobs, and also reschedule it in the event of a failed job. Now this is the most heavy lifting operation of MapReduce due to its inability of job tracker to monitor many slaves, which is the main reason for the scalability issue of MapReduce. It is responsible for allocating resources for applications to execute. But the resource manager is a greedy guy. He doesn't provide resources for other applications to process and hence other applications like graph applications cannot be executed. So whatever the user wants to do, he has to do it with MapReduce only. Also, it is very inefficient in resource allocation. To solve these issues, MapReduce in Hadoop version 1 is split into two parts in Hadoop version 2. The two parts are MapReduce version 2 and YARN. Let's see how it is done and how it resolves the issue. We know that MapReduce in Hadoop version 1 contains three parts: API, framework and resource management. Now in version 2 of Hadoop, the MapReduce takes the framework part which takes care of the entire workflow of MapReduce operation, and the resource management responsibility is taken by YARN. We will see how this is going to help answer the three limitations previously discussed. In version 1 of Hadoop, there was Hadoop which was built with two major components, HDFS and MapReduce. But in version 2 of Hadoop, there is Hadoop containing HDFS, YARN for resource allocation, on top of which MapReduce and other applications exist. It is very important to note that MapReduce is just yet another application running on top of YARN. If MapReduce needs to be executed, then MapReduce requests the YARN for resources. YARN then allocates certain amount of resources for MapReduce execution. So this gives space for other models like graph models to be executed. Hence the first issue related to execution of non-MapReduce application is resolved. Before we see how YARN solves the scalability issue, we first need to get some basics of YARN cleared out from our way. So YARN stands for yet another resource negotiator. By now I'm sure you know why it is called a resource negotiator. We already know that it is Hadoop's cluster resource management system. So we saw that the resource management responsibility was taken by YARN from MapReduce. Specifically, this resource management was handled by job tracker in MapReduce. Now after YARN has taken over, it has split this operation into two parts, resource manager and per application master. We will next see what these two components of YARN are and how it helps to resolve the scalability issue. Scalability issue was caused because of the inability of the job tracker to monitor the progress of MapReduce process in large number of systems. This was because job tracker was executing in a single powerful machine. But now YARN is distributing these responsibilities to the slave machine, thereby reducing the stress on a single machine. We have the job tracker split into resource manager and per application master of YARN. Now the resource manager, which usually runs in some powerful master node, is responsible for scheduling the job and allocating resources for the application. It does not perform any monitoring operation. The per application master, as the name suggests, is a process which is present for each and every application. In other words, if there are 100 MapReduce applications, then there will be 100 application master. It runs in the slave machine and is responsible for monitoring the progress of that particular process. Even though the application monitoring is a heavy job, since there are thousands of systems in the cluster, the load of monitoring process is distributed among those systems. This paves the way to scale even further. We will recap the responsibilities of resource manager. It is the boss which allocates resources for every application that needs to be executed. It's a pure scheduler and does no monitoring. It needs to respond quickly to resource requests and scheduling, and hence runs on a powerful system like the master node. Now about application master, as already discussed, there is one application master for each and every application. It executes on the slave node. It negotiates with the resource manager for cluster resources for execution of its applications. Some other important components of YARN are containers. It is simply the name given to the resource allocated by resource manager to a particular application. For example, the resource manager might allocate 1 core 2 GB RAM from the cluster for a particular application to execute, and this allocated resource is called as containers. Node manager is a process running on the slave machine which takes instructions from the resource manager. It is used for creation and deletion of containers in that particular node based on the instructions from the resource manager. Let's understand the working of YARN with a simple animation. You have resource manager running in the master machine and node manager running in the slave machine. When someone submits the MapReduce job to Hadoop, it is directly forwarded to the resource manager. The resource manager finds the available node manager and instructs it to create application master process so that it can take care of the program which has been currently submitted. Based on the instructions from the resource manager, the node manager creates the application master. Then the application master analyzes the code and negotiates with the resource manager for resources on behalf of the application. Based on the request from the application master, the resource manager searches for the required resource and instructs node managers to create containers. Then the connection details of the containers are returned to the application master. The application master makes use of it to run the application. Once the execution is completed, it intimates the resource manager, and resource manager instructs the node manager to delete the containers based on which they are deleted. So this is how YARN gets executed. Alright, we are done with the 5th part of Hadoop tutorial series. It would really encourage me if you can like this video. If you have any doubts, you can contact me on LinkedIn, the link which is shown on the video. Hope you guys enjoyed and thanks for watching.